Hello, welcome to Cambridge Tuitions. We're going to take a look at some predictions for the non-calculator paper in GCSE Maths. So let's get started. Okay, so for the first set of questions we have convert 3/8 into a decimal. So we'll just focus on that one. Where we have a fraction and we have a numerator, which is the top one. That one I always refer to as the hero. Now, if there was a bus stop and it was raining, the hero goes inside the bus stop, so that 3 goes there. Whereas the one on the bottom, I just refer to as the, not the hero. That will go on the outside of the bus stop, so that goes over here. Now, at this stage I say how many 8s will go into 3. So how many 8s go into 3? It's 0. And then I'll put a decimal point there, a decimal point on the bottom, and I'll add a few zeros in here as there's going to be a remainder. So I will cross the 3 out and carry it over to the next 0. So now I've got how many 8s will go into 30. Now, in order to help you, you might want to write out your 8 times table. So I've got 8, 16, 24, 32, 40, 48, 56, 64, 72 and 80. So I've got how many 8s will go into 30. Now as you can see, 8s into 30 will go once, twice, 3 times. So I'll put the 3 on the top there, and there's a remainder from 24 to 30 of 6. Now I've got how many 8s will go into 60. So 8s into 60 will go once, twice, 3, 4, 5, 6, 7 times. And the gap from 56 to 60 is 4. So I'll put that 4 over there. And now I've got how many 8s will go into 40. And you can see that that's 1, 2, 3, 4, 5 perfectly with no remainder. Therefore, converting 3/8 into a decimal will just be 0.375. So I'll just write 0.375 there. There's that one. Now the next one says, what is 7% as a decimal? Now 7% is effectively 7 over 100 because percent means out of 100. So that's 7 divided by 100. You could do a bus stop on that again, or a shortcut would be just to do 7 with a point on the end for the decimal point, and you're dividing it by 100. So the fact that you're dividing by 100 means you need to move 2 spaces back to the left. 1, 2. I'll now put that decimal point there, a 0 here and a 0 in this gap. Therefore 7% as a decimal will just be 0.07. Of course, if you want to use the bus stop method and that's your preference, you're welcome to do that as well. You'll get the same answer. So the next one is fractions, and we have work out and give your answer in its simplest form. You've got a part A and a part B there. So for the first part, it's 4/7 divided by 18 over 21. Now with dividing fractions, the rule that everybody remembers quite well, keep, change, flip. So you will keep the first, I always write this out just to make sure that I've got it embedded there. Keep the first fraction the same, 4/7. Change the divide to its inverse, so the opposite of divide is multiply, and flip the last fraction upside down, so it's 21 over 18. Now with multiplying, I don't need to have the same denominator, so I can just go straight across the top and straight across the bottom. So that will be one method, but it will give me some big numbers. So if I use that method 1, so I'll just write method 1 really tiny there so that I can fit both in hopefully. I'll go straight across the top, so I'll have 4 multiplied by 21, and on the bottom I'll have 7 multiplied by 18. Now for that one, 4 multiplied by 21 I know is 84. If you don't know that, you can do a grid method as well, or a column method just to work that out. And 7 multiplied by 18 I'll just do a quick little grid here just to show that one, because their numbers are a little bit unorthodox. So 7 is being multiplied by 18. So I have 10 multiplied by 7 first, which just gives me 70. 8 multiplied by 7, which is 56. And these two added together give me 126. Now at this stage you should notice that I have two even numbers, therefore they can simplify further as well. So I'll say both of them can half, they both have 2's going into them, so that can become 42 over 63. And at this stage I know that 42 and 63 are still quite large numbers and they both have 3's going into them. So at that stage I will check how many 3's go into both of them by doing a little bus stop. So I'll do 42 and how many 3's go into it. 3's into 4 go once, remainder 1. 3's into 12 go 4 times, so the 42 becomes 14. For 63 I'll say how many 3's go into 6, it'll be 2. How many 3's go into 3, it'll be 1. Now I've got 14 over 21, and then I should know that both of them can simplify again because they're in the 7 times table. So 7's will go into 14 twice and 7's will go into 21 3 times. That won't simplify any further, therefore my answer is 2/3. Now if you don't want to use that method and you'd like to use a shortcut one, because there's more scope to make mistakes there's a few lines of working, you could do the cross simplifying method. So you could go back to the purple and you look at the opposite diagonal. So 4 and 18, 2's will go into 18 9 times, 2's will go into 4 twice, and 21 and 7, 7's will go into 7 once, 7's will go into 21 3 times. Now on the top I have 2 multiplied by 3, on the bottom I have 1 multiplied by 9, which gives me 6 over 9, and then I can see that 3's will go into both of them, so it'll be 2 over 3. So it gives me the same answer there. That one's method 2, that's just a shortcut with cross simplifying. Part B, however, slightly different one. It's a subtract, so it's 6/8 take away 2/5. The denominators need to be the same, which in this case they're clearly not. So I take my 8, which is over here, and I multiply this fraction by 8 on the top and on the bottom, and I take this 5 over here and I multiply the top and the bottom of this first fraction by the 5. I do the maths, so that will give me 30 over here over 40, take away 16 over 40. Now you never add or subtract the bottom, so the denominator doesn't get added or subtracted, but it does need to be the same when it's a subtract, so that will be over 40. 30 take away 16 is 14. That can now half, both of them can, so it'll be 7 over 20, and then nothing will go into both of them, so my final answer is 7 over 20. So for this one we have a slightly wordy one. So we've got 4c add d equals 8 and 12x add 10y equals 40. Show that 12c add 3d has a greater value than 6x plus 5y. Now this seems really overwhelming because there's so many different variables and letters and numbers going on. You need to show something is greater than something else, and it doesn't quite correlate to what we're given on the screen. So my first thing is just to break it down and kind of stay calm. So my first part is 4c add d equals 8. And the thing that correlates in the show that line to that is the bit with the c and the d in it. So I'll just focus on that first. I'll say 4c add d is equal to 8. And I've got 12c add 3d. Forgotten the c there, so I'll just do that bit again. So I've got 12c add 3d. Now it doesn't tell me what that's equal to, but I need to go from this line over here to this part over here, and you should notice to go from the first line to the second line you're just multiplying by 3, so you could do the same on the other side as well. So you take your 8 and you multiply it by 3. I always say it out loud in my head, so I'm like 8, 16, 24. So I know that that bit will be 24. So I know the answer for that is 24. And then I'll switch to the other section, which I'll do in a different colour. So I've got 12x add 10y is equal to 40. And that bit correlates in terms of x and the y, so the variables, to the 6x add 5x. So I'll do a similar thing again. I'll write 12x add 10y is equal to 40. That's what I was given. And the one that I'm also given is 6x add 5y. I don't know what that's equal to at the moment. But what I do know is to go from my top line here to this bottom line. I should notice that the bottom line is just half of that top one. So I've just divided everything by 2. So I'll divide the 40 by 2 as well. 40 divided by 2 is 20. So on this side I'm dealing with 20. And it's saying show that my purple bit now, because I've changed the colours, brought it to a whole new level, has greater value than the orange bit. So is the purple bit greater than the orange bit? Yes, it is. 24 is indeed greater than 20. And this is a little bit of OCD that my students know that I have. When it's a show that question, just for completeness, I tend to write QED, which is Latin for therefore I have proved what you have asked. And that's it. That question is as simple as that. Hopefully everyone's having fun so far. So this next one is solve a add 11 divided by 4 is equal to 7. So the 4 is the denominator, so it makes it a fraction, and that's a bit of a problem for us. So we need to get rid of that first, because when I say it out loud, it's a add 11 and then it's divided, all of it's divided by 4. So I need to do the inverse of dividing by 4. So the opposite of dividing by 4 is multiplying by 4. So I do that on that side and I do it on this side. Now, just as a bit of an aside, that left hand side, I'm just going to do this little blue bit here to show you that I'm taking the left hand side to the side. So I've got a add 11 and it's divided by 4, and the action that I'm saying that I need to do to it is multiply by 4. Now when I multiply by 4, they cancel and I'm just left with the a add 11, which is why on this side I'll have a add 11, and on the right hand side I've got 7, which you can see here, multiplied by 4. So that bit is 7, 14, 21, 28. If you need to write out your times table to help you, do that, but please don't make a mistake in your mental maths at this stage. Now on the other side I've got left a add 11 equals 28. The inverse, so the reverse of adding 11, is taking 11 away. So I'll take 11 away from both sides, and just as I did before, this left hand side, I'm going to show you to the side. So I have a add 11, and I'm saying that I need to take away 11. Therefore those bits just cancel and I'm just left with the a on that left hand side. And then I've got 28 take away 11. Again, if you need to write out 28 take away 11 and do the subtraction where you'll get 7 here and 1 to get a equals 17, then do that instead of making a mental maths error. There's no problem if you do that. It's going to be a problem if you do get it wrong though in your mental maths. So if you need to do the little grid and stuff on the side, do it. And that's that question done too. So for this next set we have some cheeky little dividing and multiplying with decimals, which always tends to catch students out, but not if you guys watch this. You're going to know how to do it. So I've picked dark green for my first question, which is work out 18.4 divided by 0.04 or 0.04 if you prefer. So the key thing here, I've picked dark green because it's a divide, so dark divide, alliteration and all of that. Hello English language buffs. So divide with dark green. Now the trick with this means don't move back. So dark green, divide, don't move back. If you're like, what is going on? Don't worry, it will all make sense in a moment. So the first objective is to take my 18.4, write it out divided by 0.04, and I need to turn them both into integers. Now integers are whole numbers, so both of them need to turn into integers. Now if I moved this decimal place to the right once, that would turn it into an integer, but then I need to do the same movement here. That would not turn the 0.04 into an integer. So I need to move it twice on the 18.4, and I need to do the same on the 0.04. So I've made two movements here, and I've made two movements here. Now the 18.4, you can see there's a gap there, so that will be filled with a 0. That will turn into 1,840, and that's being divided by 004, or in other words 004, which is just 4. So now I've got 1,840 divided by 4. You could do that in two ways. You could either do the classic bus stop, where you just say how many 4s will go into 1, 0, how many 4s will go into 18, and if you want to, which is probably advisable, you can write out your 4 times table to help you, just so that it's a little bit easier and you minimise the chance of making a careless mistake or a mistake under pressure. So now I've got 4s into 18 will go 1, 2, 3, 4 times, and the gap from 16 to 18 is 2. 4s into 24 will go 1, 2, 3, 4, 5, 6 exactly, and 4s into 0 goes 0. So I've got an answer here of 460. Now if you remember the dark green thing, I said divide, don't move back. We moved the decimal place out to turn them into integers, and it had to be the same number of movements, but we don't move it back because of the reason that we moved it the same number of decimal places to begin with. So actually my answer to 18.4 divided by 0.04 is 460. So I'll just write that underneath here as well. Okay, slightly trickier to find a colour that begins with M. I'm sure lots of people will be telling me colours that begin with M later. I know mauve is one, don't really want to use that, don't even know what colour that actually is. So let's go with a little red, which is the opposite of green. Now we've got work out 27.6 multiplied by 0.58. Now multiplying is what the name of the game is here. Multiply means move back. So unlike with my dividing, when I multiply I do need to move back at the end as well. Now here it doesn't need to be the same number of movements, the focus just needs to be to turn them into integers. So the 27.6 I can move it once, the 0.58 I can move it twice, and they will turn into 276 multiplied by 58. Now it's times like this I kind of wish I knew that off the top of my head so that I wouldn't have to do all of this grid stuff, but if you're like me and you don't know it off the top of your head, then you can just do a grid. So we've got 58, which is being multiplied with 276. It doesn't matter which way you put the 276 and the 58. Oh, if you want to put it the other way around as well, that will work too. So we have 200 multiplied by 50, or I tend to do 2 multiplied by 5, which is 10. And then there's 1, 2, 3 zeros, so I'll add in 3 zeros to give me 10,000. 5 multiplied by 7 is 35, and then there's 2 zeros, so 3,500. 50 multiplied by 6, or 5 multiplied by the 6 is 30, and then there's a 0. Then I'll do this bottom one here. 6 multiplied by 8, 48. 70 multiplied by 80, I'm going to have to think about that one, or I could do 8 times 7, which will give me 56, and then add the 0 in there, and 200 multiplied by 8, or I could do 2 multiplied by 8, which will give me a 16, and then 2 zeros. Now at this stage I just need to make 100% sure that I've done the correct maths and I haven't made any errors with zeros or with my multiplying, otherwise my answer will be wrong and it will be a lot of work for kind of not much gain. And then at this stage I just add all of the numbers together which are in my grid there, so I'm just going to circle it so you know where the focus is there, and I'll write 10,000, add 1,600, add 3,500, add 560, add 348, so I can just merge those two, 3, 4, 8. Be careful of doing that in the exam though. And then I just get adding, so that one is going to be 8, this one will be 10, this one over here, slightly trickier, will be 10, 19, 20, this one over here will be 4, add 2, 6, and then I've got a 1, so I've got an answer of 16008. Now this bit is really key, don't forget this little bit here. I moved my decimal places a total of once and twice there, which gives me a total of 3 movements. 3, it's a magic number, so I'll add my decimal place on the end and I will move it back in 3 times. So once, twice and 3 times to get a final answer of 16.008. And that's it. I've multiplied and I've divided the fractions on that, the decimals on that page. So the next question we have is write down the column vectors represented by the arrows for A and B. Okay, so with the first one, you can see it's going from the left to the right. So it's going from this point here. Might be a better idea to use different colour, I think. Going from this point here to that point here. And just with our x and y axes, when we do things with graphs, we always go across first and then we go up. So I'll count how many I'm going across. I'm going across 1, 2, 3, 4, 5. So I've gone 5 to the right. And from that point I've gone 1, 2 up. So I've gone 5 right and 2 up. Now when we do column vectors, if we're moving to, we always refer to the left and the right first. If it's going to the right, that's a positive direction, so that will be a positive 5. And 2 up, if we're going up in the world, that's a positive as well. So that will be 5, 2, and I just put it in a set of brackets. I don't need to write a divide line or anything, it's not fractions, it's just a column vector. And the second one, I've got B as my focus, so I'm just going to switch colours here, just because I'd like to, and it's moving downward, so it's going from this point here to that one there. So in terms of movements left and right, we always go in terms of left and right first, and then we go up and down, because we can't fly, even though we can in our hearts and minds, but physically we can't without any assistance. So I'm moving from this point here, 1, 2, 3. So I've gone 3 to the right, so I'll just write that out, 3 to the right. And I've gone from that corner there to this one, so I've gone 1 down. Now movements to the right are positive, so 3 to the right will be a 3. 1 down, well if we're going down, that's a negative thing. So I'll write -1 and I just put that in a bracket as well. Boom. So the next one, now that we've done the sonic boom, feeling energized again, ready to smash out the next one, is a work out 3x minus y when x, which is a vector, so it's a column vector, is equal to 4, 9, and y, which is another column vector, is equal to 8, -3. So this one's literally a case of substitution, but as we have a 3 in front of the x, that's a scalar one, so the x needs to be multiplied by 3. That's the top and the bottom of that one, and we need to subtract y. So the way I like to do this is my 3, which is being multiplied by x, I will write that on the top and on the bottom. 3 multiplied by, 3 multiplied by, and x, as you can see, is 4, 9. So it's 3x, I've done that bit there, which I could put in a small bracket, so I could put that one in a small bracket, that one in a small bracket, but they're all in an overall bracket. And I need to take away y. So what I could do for this section is for my y, I'll just switch to a different colour. I'll use this kind of goldy brown colour. I need to take away y, which on the top take away 8, on the bottom take away -3, and then I just close that bracket there and I do the maths from left to right. So on the top I've got 3 multiplied by 4, which is 12, then I've got take away 8. On the bottom I've got 3 multiplied by 9. I always do it in my brain where I say 9, 18, 27, so that bit's 27. And then it says take away -3, so the two negatives become a plus, and that will be +3. And underneath I do the maths. 12 take away 8 is 4. 27 add 3 is 30. And I just double check that I haven't made any careless mistakes. I double underline my answer. That's another boom right there. This one is surely a badass epic question because it's solving simultaneous equations, which I kind of think if you get this it's kind of a blessing, but some people kind of hate these. But if you watch how we work through this, I like to start at the beginning in both of them to make a good foundation. So my focus will be the F's, because that's a common theme sometimes. So we have, oh, it doesn't want to seem to underline there, but that's fine. We have the 2f add g equals 15 and 5f minus 2g equals 42. They've both got to be the same, otherwise we can't eliminate anything. So for my first line, I'll take the 5 that I had from the bottom, so this 5 here, and I'll multiply everything on the top by that 5. And for the bottom one, I'll take my 2f that I've got there and I multiply the bottom one by 2 because that will make them the same. So I take the whole of the top line and I multiply it by 5, so I end up with 10f add 5g is equal to, now 15 multiplied by 5, shortcut for that you could do 15 multiplied by 10 and then half it. So 15 multiplied by 10, 150, halved is 75. Or you can do your little grid or column multiplication so that you don't make an error there. The bottom I need to multiply everything by 2, so I end up with 10f take away 4g is equal to 84. So as you can see now, they are both in terms of 10f at the beginning, so that they are the same, which is great because it means that I can take away everything on the top, everything on the bottom from everything on the top. So I will just go there. Just going to move this over a little bit so it's a little bit more centralized, just to address that a little bit nicely. So on the top I have 10f take away 10f. That bit will just give me nothing, so I don't need to write anything there. If you really want to write a 0, you can. Then I've got positive 5g, so I could write that on the side. Take away, in green, negative 4g. Now the two negatives become a positive. You've got to be really careful here. So that bit turns into 9g. And then I have 75, take away in green 84. Now obviously it's a small number, take away a bigger one. So I need to be really careful with that one to make sure that I don't make an error with the maths, but it will be a negative. It will be -9. And at this stage I need to get g equals, so I will divide both sides by 9. So this 9, which is over here, I need to divide both sides by 9. So I end up with g equals -1. So my g is -1. And then I'll take my g, nice, just take my g, and I will substitute it into the first equation. So I'll substitute it into this one over here. So I'll just write that whole thing out again. 2f add g equals 15. And instead of g, that's where I will write my -1. So -1 is going in the space of g, and everything else just gets filled in around it. So 2f add equals 15. Now the add and the minus just makes a minus because different signs give us a minus. So I've got 2f take away 1 equals 15. I now need to solve this equation. So I'll have to add 1 on this side and add 1 on this side, which will then take me to a point of 2f equals 16. And then I need to get rid of the 2 that's being multiplied by the f, so I divide both sides by 2, and then that ends up giving me f on that left hand side, and 16 divided by 2 is just 8. So my solution with a squiggly line there is f equals 8, and if you want to, on your dotted line, f equals 8 and g equals -1. And I don't have a dotted line here, so I'm just going to do a solid one to show that that's my final answer. Very clear, methodical and systematic approach to solving simultaneous equations. That's it. Okay, so if you've made it this far, well done. You've made it to the end and you are going to smash it out of the park, which is what we hope. So there are some foundation section questions which could come up. Obviously you'll get some wordy questions, and it's definitely advisable to learn your square numbers up to 10, and definitely your cubes. If you can learn them up to 10 as well, that would be great, because that will just help you out. Your multiplications and your times tables, divisions and things, all of those things will be factored in as well. But really read the question to make sure that you understand what's being asked. If you want to use your highlighter to highlight key facts, just to zone in and to break the wordy questions down, that will be helpful as well. Working out will help hopefully get you some marks. So if you're struggling, instead of leaving it blank, try to give some form of an answer, and that's it. As I said in my previous one, I'll just give you our, oh, this is moving around now, but here's our, be sure to subscribe on Instagram, YouTube and Facebook. And if you have any questions, you can hit us up on Instagram. Good luck.